Greetings. In this problem, we're going to calculate the radius of a polonium ion, knowing its density and the type of unit cell it makes. Okay, now, in all of these types of problems, there are basically three steps. The first step is calculate the volume of the unit cell. And I'm going to write UC for unit cell. Once we know the volume of the unit cell, we do the second step, which is calculate the length of a side of the unit cell. And these are simple cubic cells, so they're all equal. And then the third is knowing the type of unit cell and the length, we can calculate the radius. Okay, and this varies the approach on the type of unit cell. As we see up here for this problem, it's a simple or primitive cubic, and the length is twice the radius. If it was a face-centered cubic, you would take the diagonal across a face, and that would be 4 radius. If it was a body-centered cubic, you take the diagonal through the cell, and that would be 4 radii. Okay, and we'll look at each of those later. Okay, so for this simple primitive, we have 1 atom per unit cell. Okay? Now, if it was a body-centered, there would be 2 atoms per unit cell. If it was a face-centered, there would be 4 atoms per unit cell. Now we need to calculate the number of moles in a unit cell. So we know that there are 6.022 times 10 to the 23rd atoms per mole of polonium. Okay? Now, in this problem, we're working with polonium, so we need to figure out the mass of the polonium in the unit cell. So we need to look up the molar mass of polonium on the periodic table, which is 208.9 grams per mole. We want the moles to cancel, so we have 208.9 grams of polonium per mole. Okay, and now this tells us the mass of polonium in the unit cell. The atoms have canceled, the moles have canceled. And we now want to go to volume. That's what we're after, the volume of the unit cell. So we need density, because density allows us to go from mass to volume. And this is a macroscopic thing that we can measure in the lab. And polonium has a density of 9.32 grams per mil. We want to get rid of the grams, so we're actually dividing by the density. 9.32 grams per milliliter of polonium. Okay, now we get out the calculator, okay, and I notice I have a 1 here, so I'm going to just type in 6.022 EE23 and hit the reciprocal sign, okay? Now I'm going to multiply by 208.9 and divide by 9.32, and this is equal to 3.72 times 10 to the minus 23. 3.72 times 10 to the minus 23. And this is mils, but I'm going to convert my mils to centimeter cubed. Remember, a milliliter is a centimeter cubed, because in the next step I'm after length. So I'm just going to call this centimeters cubed, which is the same thing as milliliter. Okay? Now, for a perfect cube, the volume is the length cubed, because each of the sides are the same. Okay, so we're calling L the sides of each one. Therefore, the length is the cube root of the volume, which is equal to, now I'm actually in the calculator going to do this to the power of 1/3, which is the same thing as cube root, so it's 3.72 times 10 to the minus 23 to the power of 1/3, which is the cube root. So I still have that value on my calculator, and I simply go y to the x 0.333333, a bunch of those, and I get 3.34 times 10 to the minus 8 centimeters, okay? And remember that the cube, I should have centimeters cubed here. The cube root of centimeters cubed is centimeters. Now, this is in scientific notation, and I want you people to be able to use angstroms. Recognize angstrom is the units that are the scale of the distance between atoms. 1 angstrom is 10 to the minus 10 meters. Okay, this is not an SI unit, okay? This is only for meters. Centi is 10 to the minus 2, so 1 centimeter is 10 to the minus 2 meters. Now, I could say a meter is 10 to the 10 angstroms, that is 10 to the 10 times 10 to the minus 10, or it's equal to 10 squared centimeters. So I'm going to convert this in one step and say that 100 centimeters, that's 100 times 100th, a centimeter is 100th, is equal to 10 to the 10 times 10 to the minus 10, which is angstrom, okay? And this now gives me a value of 3.34 angstroms. So this is the length of the unit cell, okay? Now I need to go to the radius, and for this particular type I have to look at the geometry, at the structure, and I can see that for a primitive cubic cell, the length is twice the radius. So L equals 2R, therefore the radius equals L over 2, which is 3.34 angstroms divided by 2, which is equal to 1.67 angstroms. Okay? And realize that if I had applied this to other types of geometries, this last step would have been different, and the first step would have been different. The differences would be how many atoms per unit cell. That depends on whether it's face-centered, body-centered, or simple. And then the relationship of the radius of the atom depends on how they're stacked into the cubic cell. Okay, hopefully this helps.